Hi everyone. So we're finishing up lesson 5.1 for calculus. So you'll see I have example 5 written on my board here. And you'll notice something very interesting about this one. They've given us y equals sine x, y equals cosine x, and they want us to do the integral from x equals 0 to x equals pi over 2. But notice on my graph, when I tried to graph that, and I tried to just make sure of what was going on, that the graphs actually cross. Notice y equals cosine x is this function right here, okay? And y equals sine x is going to be this one. But when we're trying to determine which function is on top or above the other one, we can't tell because for sometimes the cosine function is going to be above. For other times, the sine function is going to be above. So what we're going to do is we're actually going to set this up as two separate integrals. One where the cosine function is on top, and we'll do that integral from 0 to this point where they cross, and then we'll set up another integral from this point onward. Okay, so that's just going to have us reversing which one's f of x and which one's g of x. Okay, so you may remember from pre-calc that the place where y equals cosine is equal to y equals sine is right here at pi over 4. Because cosine and sine have the same values when x is pi over 4, and that value is going to be the square root 2 over 2. Okay, but we're only really interested in the x value for that anyway. Okay, so let's set up our integral. So we have the integral from 0 to pi over 4. Now that's this part here where the cosine's on top. So from 0 to pi over 4. So I'm going to do cosine x minus sine x. dx. Now I want the total area, so I'm going to add it to the integral from pi over 4 to pi over 2 of, now in this case, pi over 4 to pi over 2, the green function's on top, that sine function. Okay, so sine x minus cosine x dx. Okay, so now all I have to do is take these integrals. So you'll remember that the antiderivative of cosine x is sine x. Okay, and the antiderivative of negative sine x is cosine x. Now the sign did change because this was a negative, and when I do the derivative of cosine, I get negative sine. So this is a cosine x. And this has to be evaluated from 0 to pi over 4. Okay, and then I'm going to add. Now I needed the integral of this, so the antiderivative of sine is negative cosine x, and then the antiderivative of negative cosine x is minus sine x. And this is evaluated from pi over 4 to pi over 2. Okay, so now what we're going to do is put in values from pi over 4 and from pi over 2. So at pi over 4, sine x is the square root of 2 over 2. And it's plus the value of cosine at pi over 4, which is square root 2 over 2. And then I'm going to subtract out the values of sine and cosine at 0. Now at 0, the sine value, let's remember, at 0, okay, we're at the point 1, 0. So sine is 0 and cosine is 1. So I'm going to have 0 plus 1 here. Okay, so that's this evaluation. Now next, I'm going to go on to this part. So it's plus, in parentheses. Now the value of cosine x at pi over 2, that's going to be up here. Okay, so this is the point 0, 1 on my unit circle. So cosine at that point is 0, so negative 0, which is basically just 0, minus the sine value at that point. Sine is 1. Okay, and then it's going to be minus Now I need the values at pi over 4 again. So negative square root 2 over 2 minus square root 2 over 2. Okay, so these are the values at pi over 4. Okay, these are the values at pi over 2. Now I just need to calculate this. If I actually was to add these two, I would get 2 times the square root 2 over 2. And these 2's would actually just cancel. Okay, so this whole thing adds to the square root of 2. Now it's minus, and 0 plus 1 is just 1. And now I'm adding here, so plus. And 0 minus 1 is just negative 1. Okay, and here I'm subtracting. And when you add these, you get negative 2 square root 2 over 2. And these will cancel. So it's negative square root 2. Okay, now this is a little work with my signs, but notice this negative 1 and this negative 1 combine to negative 2. And square root 2 minus negative square root 2. I'm going to leave the sign, change to plus, and change the sign here. So square root 2 plus square root 2 is 2 square root 2. And that's it. So the total area is exactly 2 square root 2 minus 2. And that's going to be the total area between these two curves. Okay, so this total gray area here plus this total gray area here is going to be that. Okay, so we have one more example. Okay, and in this example, what they've done is they've given us something that it's really hard to get x alone. Okay, so here's my example. Okay, they want us to find the total area between the curves, but this time they gave us y equals x minus 1 and y squared equals 2x plus x. So it's very, very difficult in this one to get the y alone, because when you do that, you're going to do your own square root, and you have to put a plus or minus sign there. And we're not quite sure how to do the integral of that. So what I'm going to do is in both of these equations, I'm going to solve for x, and then do my integral with respect to y. So in this one, to solve for x, I'm just going to add 1. So I have y plus 1 equals x. And in this one, I'm going to subtract 6. And I'm going to divide by 2. So this becomes 1/2 y squared minus 3. So these are the two functions that I'm going to graph. Now, again, I earlier recommended an online graphing calculator for this. I really highly recommend it because your regular graphing calculator does not do things in terms of y. Okay, so this is the graph I got. Now, the big question is, how can we tell which one is the upper function, the higher function, and which one's the lower function? Because now we're talking in terms of y, okay, and not x. So what happens is we actually change it to be the function on the right and the function on the left. And the one further to the right is going to be the, quote, upper function. And the one further to the left is going to be the lower function. So this blue function, which is x equals y plus 1, is going to be the upper function, or f of x. And the green function, okay, which is the 1/2 y squared minus 3, is going to be the lower function, or the g of x. Okay. Now, again, I had the computer software calculate those intersection points. This point right here where they cross is the point 5, 4. Okay, and this point over here where they cross is the point -1, -2. Okay, so what I need for my integral, let me get my whiteboard back. Okay, I need the integral of the blue function, which was y plus 1, minus the green function, which was 1/2 y squared minus 3. Now it's in terms of y, And I'm going from -1 to, oops, wait, not -1. We're doing it in terms of y, so I pick the y values, -2 to 4. Okay, I picked the y values from those intersection points. Let me bring it back up again. Okay, the intersection points were 5, 4, and -1, -2, and I picked the y values because we're doing our derivative in terms of y. So I did the lower y value and then the upper y value. Okay, so now let's just do our integral. Okay, this can simplify. So I have the integral of -2 to 4. I have -1/2 y squared plus y minus 2 dy. And all I did was I combined like terms. Now I'll just use the power rule. Oops, I forgot my parentheses. Sorry about that, which means I got a wrong number right here. So 1 minus -3 is +4. Sorry about that. So now I'll just do my antiderivative, go up by 1, divide by that power. Okay, so I just multiplied 2 times the 3 that I was dividing by, and that got me -1/6 here. Here I'll go up by 1, divide by that power. And here I'll go up by 1, and that power was just a 1, evaluated from -2 to 4. Okay, so 4 to the third power is 64, so I have -1/6 times 64 plus, and 4 to the second power is 16, and half of 16 is 8, and plus 4 times 4, which is 16. And then I'll subtract. This time I'm not going to forget my parentheses. -2 to the third power is -8 times -1/6 is 4/3. The negatives will cancel, and I reduced my fraction. -2 squared is 4, and half of 4 is 2. And -2 times 4 is -8. Now, if you combine all of this together, you get 18, and I just put that into my calculator. You could also get common denominators for this, and the 64 and 6 will reduce, and that will also have a denominator of 3. But anyway, this is the area between those two curves. Okay, so that's it for this lesson. So you'll have some homework posted, so don't forget to do that.